Good afternoon all, how are you? Well, I'm good because today I'm thinking of assembling one or maybe even more than one of these PWM5 solar charge controller gumstick version. This is the gumstick, the sort of long and thin version, mostly surface mount solar charge controllers. So I'm sure you've seen the PWM5 before. Now this was the original Vero board version, built on Vero board or strip board. This is a printed circuit board version, but it was only ever single-sided. There are a couple of surface mount components on here actually, but this was laid out very much to mimic the layout of the Vero board one. So you can see that in terms of component positionings, very little changed between those two. But the gumstick version is quite a departure from the previous version because this is long and thin. It's mostly surface mount. I have left a few through-hole components on here. But yeah, mostly surface mount, but really only surface mount components on this top side. Later on, I want to do an improved version of this, a much smaller version of this, where I've got almost all surface mount components, with the possible exception of the MOSFET, but I'll come back to that. And I'm going to put components on both sides of the board. Now, these 10 circuit boards have come from JLC PCB, and I'm very pleased to say that JLC PCB are actually sponsoring this video, so that's excellent. Now, these boards turned up in a DHL package a couple of days ago when I was making another video, so I'm just going to insert some shots from that day when I actually opened these up. Right, now today is such a lovely day, I don't really want to spend too much of it indoors, so but I just wanted to take a quick look at this, because these are the new PCBs for the PWM solar charge controller, my PWM5. Let's take a quick look inside this box. And oh, I've got another pen. Fantastic, excellent. And here are the printed circuit boards. So let's quickly have a quick look at these. Of course, I'm going to do another video where I actually start to assemble one of these. But oh yes, they look nice. Let's tear the packaging, open these up. Oh yes, how I remember staring at that for many hours. Yes, that's going to be great fun to build. Let's get in a little bit closer. Yes, so mostly surface mount 8-pin microcontroller there. That's the PIC 12F683. Resistors, capacitors. The only things I didn't surface mount were 3 tantalum capacitors, a voltage regulator. I have found a surface mount replacement for that now. The transorb, the transient suppression diode. I bought some surface mount versions of those actually. In fact, I've bought the regulators as well. Now, it's possible that the MOSFET will always remain. This MOSFET, incidentally, will lie down, and that is a hole that should roughly line up with the hole in the MOSFET. That may remain through hole indefinitely because of the way I think I might connect the flying leads, the wires, to the MOSFET. Here I've actually run some tracks on the back, but on the original design I soldered the flying wires directly to the legs of the MOSFET, so of course there were no issues with current flowing through PCB traces. But this is only a 5 amp, hence the PWM5, a 5 amp solar charge controller. These traces should easily be able to take 5 amps. There are no wires on here, interestingly, because the only points where the top side had to link through to the bottom side were at pads. So there are some lines that run into these pads and they effectively work as wires. But yeah, video coming up soon where I solder one of these and try and get it to actually be a charge controller. Now, I just wanted to briefly show the process. I'm using Easy EDA for designing this circuit board, and I just wanted to briefly show the process of generating the Gerber files. So I click up here and say generate Gerber file. Now that brings up a window which shows me a Gerber preview. I can generate Gerbers, but for me, because I'm going through JLC PCB, it's easier just to click this button down on the bottom right, order at JLC PCB. I just need to specify the quantity of boards. Well, I might as well have 10 because they do 10 for $2 plus shipping. First time order, the shipping is free. Select the thickness of PCB, 1.6 millimeters, color green, with lead I wanted on this occasion, and a copper weight of 1 ounce. I then simply click order at JLC PCB. It says you're going to be redirected to that website, which is fine by me. So I'll just wait for that to come up. And then on the JLC PCB website, it starts adding the Gerber automatically for you. So it's nice and simple. Here's the Gerber preview. You can have an SMT stencil if you want. I didn't on this occasion. So I need to just check some of these details. Number of layers is 2. Dimensions is shown there, quantity 10 and 1.6 millimeters for the PCB thickness. Save to cart. It's that simple. Right, good, excellent. So back to today, and so I've explained quite a lot about this, so I think without further ado we should actually get on and start soldering components on, and I think I might solder that capacitor first. Why that capacitor first? This little surface mount 100N, which is right next to the microcontroller. Well, I think if I'm going to do this in a logical sequence, it would make sense to put the power supply, well, the voltage regulator components on first, apply a 12 volt supply to that, and just make sure that we've got 5 volts which will go to the microcontroller. So the regulator circuit consists of this 3-terminal regulator, the LP2950, which is a low quiescent current, low dropout 5 volt regulator, input capacitor 1 microfarad, output capacitor 4.7, although I'm going to put a 3.3 in because that's what I've actually got. 100N, which is close coupled to the microcontroller, and you can just about see that. There's the microcontroller, there's the 100N right next to it. I'll also need this diode in order that when I apply VBAT, which is the 12 volt battery power supply, this will all power up. So I will need that diode. Now the only thing is that diode is part of a pair of diodes, and that's where this has all got a bit muddled. The BAV99 is not these two as indicated on this diagram. It's actually these two. So they have a common, which on one diode goes to the cathode and on the other diode goes to the anode. That's the BAV99. These two here, which are common on the anode side, are actually a BAW, BAW56. So that's those two. So I'll need to fit that BAW56 in order that this diode is in the circuit and therefore that this will power up. So here's a datasheet, Taiwan Semiconductor, which shows the BAW56, the BAV70 and the BAV99. They're just 3 different variants of 2 diodes in 3 different configurations. BAW56, common anode, BAV70, common cathode, and BAV99 has the anode, the cathode of one and the anode of the other connected to that middle common pin. Now, actually on my diagram for the schematic, I've specified BAT diodes, which are again 2 diodes in one package, but the BAT device is Schottky. Now, I'm not actually going to use Schottky. I'm going to use non-Schottky. I have some BAV99s, but I don't have any BAW56. And as you can see from this diagram, it's the BAW56 that I actually need to make this circuit power up. However, there may be some hope in this package. I think you can see the outline of a strip of surface mount components there. I hope this is the right part for what I want for today. Let's have a look. Well, it's definitely surface mount components. They're definitely SOT23. Let's have a look. And someone's very helpfully written on here that the marking on this device is A1 and it's a SOT23. So let's just do a quick check that A1 is the BAW56. And yeah, here you can see that the bore 56 is marked A1, the BAV99, and I've got some of those, is marked A7, and the BAV70, which I don't need, is marked A4. Good. Now, sorry that was all a bit long-winded, but I needed to go through all that because it's clear to me that I need to fit the regulator there, the two capacitors one either side of it. This capacitor here, oh, that's actually something different. That's the charge pump. But I need D2 here. That's the bore 56, which takes battery positive. Battery is actually connected this side, but it runs through to this pin and then up onto this dual diode. That then runs into the regulator circuit, and then that 100N cap there is on the output. So let's fit the 100N cap, surface mount, and the bore 56 dual diode. Right, well now for logistical reasons, my 100Ns are in my storage unit, which is 3 miles away. I'm actually going to put a 47N as the decoupling cap across the microcontroller. It really doesn't make a lot of difference. These Y5V components also have a massive tolerance, plus or minus in value, so who knows what the actual value these are. So I'm going to put a 47N there, and then the bore 56. So let's do those two components first. Right, so let's get one of these tiny little 0805 caps out of its band. Probably should be using tweezers for this, but did it fall out? No, it didn't. Right, you come. Right, there it is. 47N capacitor. Now it's not going to make much difference using a 47N instead of a 100N for that decoupling cap across the chip, so that's fine. And let's get one of these dual diodes out. SOT23, bore 56. Now I've written some of these surface mount markings on here. So for the bore 56, that was an A1. Let's write that on. For the BAV99, which is now here, that one is an A7. So let's write that in, just so that I've got everything in front of me and so I know what I'm doing. Right, so that this board doesn't slide around on my mat, I'm going to use a little bit of blue tack on there so that that's fixed reasonably well down. Now I'm going to get the bore 56, put that in place. So that's approximately there, but I think what I'll do is probably tack it on. So I'll just tin that right hand pad and just tack that on, and then I'll solder the other pads. Let's get in a bit closer. Right, so let's try and apply a tiny bit of solder to that pad, like so. Maneuver it into position, like so, and tack it on. It's slightly rotated, but I think that's okay. So let's rotate it on my desk so that I can get to those other two pins and tack them on. The component itself seems to be taking solder pretty well. Yeah, that's fine. And in fact, the tacking of the first pin I think was good enough anyway. Okay, let's get the capacitor in place. Once again, I'm just going to put a little bit of solder onto one of the pads and then get the component, put it roughly into place, solder that side down. Yeah, that's pretty good. Now I'll rotate the board, solder the other side on, and then redo the joint on the first side. Now, rather too much solder, but it's fine. Just want to try reflowing that right hand one. So I'm just going to press down my flux pen to try and, oh yeah, that's quite a lot of flux. So just dab a bit of flux around there. That's plenty. Let's just see if that will reflow nicely. Oh, that reflows lovely with loads of flux around it. Right, so that's two components on there. It's this, what was a 1N4148, it's now half of a bore 56, and this 100N, which is now a 47N for logistical reasons. What I want now are two tantalums and the LP2950. Right, no shortage of tantalums. These are the 3.3 microfarads at 35 volts. These are the 1 microfarads, also at 35 volts. So that's those two. Right, here's a radio spares package from when I was sort of bulk manufacturing these things. You can see I've got lots of the regulators there in TO92 flavor. Lots of these Schottky diodes, more in here. Chips, microcontrollers, these are the DIP ones. I'm now going to be using surface mount, and these are the transient suppression diodes, the P6KE33CA. So it's one of these regulators that I want now. Right, this is the regulator. Curiously, it has a marking KY5050, but it is actually the LP2950. Now you can see that it's got a bit of gooey glue on the bottom of the legs, so I could cut those off. I'll see how easily they fit through the holes. And I just want to do a cross-reference with my diagram, so you can see there that I've got a drawing of it sort of in 3 dimensions, and it's output on the left, ground in the middle, in on the right. And that makes sense with this because here's my feed, that's the diode coming in there. So that runs into this capacitor, feeds the regulator, and then the output capacitor I think is on that side. That would make sense. Right, let's solder the regulator in. Center pin, which is ground, whatever that is. Can't remember whether it's input or output now. And the other one, trim the legs off, and that's done. Now, if you're thinking that I really should solder all the low profile components on first, the surface mount components, it's not really a major issue because once the legs of the through-hole components are chopped off, there's only 1 millimeter or so sticking out on that side, and I can offset that with blue tack on the back when I push this down in order to solder the surface mount components. So yeah, it's not really a major problem, and I want to get this power supply done first, this voltage regulator done first, so that I can actually power it up and test it. So tantalum capacitor on the input side of the regulator is a 1 microfarad, and this time I've actually got the correct pitch capacitor holes for tantalums, because I think I actually selected a tantalum from the library. The other one is 3.3 volts. I do have pluses on here so I can see which way around these goes. This is 3.3 microfarads, 35 volts. Let's put that in. I'll put some blue tack up against these, flip it over and solder it. Now actually it's just occurred to me that I might want to bend these components down because they do sit quite high on the board. I might want to actually bend them down for when I encapsulate this thing, if I do in fact encapsulate this one. So I'm just wondering whether I should leave a little bit of leg showing there so that I can bend those caps down. I can bend that regulator down, that's no problem. I think I will sit them just slightly high on the board so that I can fold them over later on. Yes, that looks about right. Okay, let's solder these. Oh, if I can get my iron in under the camera. It's always difficult filming soldering because it just means you have to solder in a rather strange way because you can't quite get the iron pointing in the direction you would normally have it. So it always looks a bit cack-handed when I do it on camera. But there we are. That looks pretty good to me. And in terms of assembly, I think that's really all I can do at the moment because that's this section here, the power supply, well, just the voltage regulator, with that diode. Now that actually works as an anti-reverse polarity diode. So if you connect the battery up reverse polarity, then it doesn't fry this part of the circuit because of that diode, doesn't fry the microcontroller. So that's why that's there. There's no other reason for that. But that's as far as I can go. 5 volts only goes to the microcontroller. It doesn't go anywhere else in the circuit. So what I really want to do now is put 12 volts on this connector. Could I actually fit a connector there? I don't know if I've got one, but yes, I'll just rig up 12 volts on there. I might just do it with croc clips actually. And just check I'm getting 5 volts on pin 1 of the microcontroller, which is up in that top left-hand corner. And as I say, that's about as far as I can go until I program a microcontroller. That's going to be a bit more involved, so I'll probably do that as a separate video. But let's get this voltage regulator tested now. Right, I'm going to kind of bodge this just for the moment. I'm just going to put those lines through there from this terminal block. It's probably going to be enough because these are through-plated holes to make a reasonably good contact. So let's plug that in. That should not do anything disastrous. But if I sit that there, I should be able to measure 5 volts. Let's give it a try. Right, apologies if you can't see the meter very well. The sun has just come out right when I didn't want it to. So that's ground there. That is positive of the regulator on that side of the capacitor. And yes, that's a little low, isn't it? 4.95. But then these regulators, I'll just go to pin 1 of the chip, which is there. 4.96, no, 4.95. These regulators do have a plus or minus 1% tolerance on them. But anyway, that's taking the, what is it at the moment? 13.6 volts of my lead acid battery down to 5 volts, which is exactly what it should do. So yeah, that's working. So yeah, as I say, the next video is going to be about programming this chip. Probably also take a look at the software that I'm programming into that microcontroller, because without that microcontroller, the charge pump won't work. So once that's in place, we can measure the voltage here at the far end of the charge pump. That should be about 20 volts or something like that, because it's 12 volts for the battery, or whatever the battery voltage is, plus 2 lots of 5 volts minus diode drops added to that. So we're looking at about 20 volts there. We can also see whether the LED is flashing. That'll be a good indicator that the circuit is working. But yeah, for the moment, I just wanted to get started assembling this, and I have. So I'm happy with that. So a big thanks once again to JLC PCB, not only for manufacturing these 10 printed circuit boards for me, but also for sponsoring this video. And I'll be back as soon as possible to program a surface mount microcontroller and to explain a little bit about how the microcontroller reads the battery voltage via this potential divider, flashes the LED in the numerical sequence so that you can actually see the voltage on the battery, raises this voltage here to about 20 volts via this charge pump, and then drives the high side driver circuit, these 3 transistors here, with the PWM output to switch the MOSFET on and off to control the connection between solar panel and battery. I'll be back to explain all of that, but for the moment, I'm happy with what I've done so far. Cheerio.